The pulse width modulation core driver is actually included inside the GPIO core. And the reason why is because it resembles the GPI core. So if you would take a look at the header file just to see what's implemented in that pulse width modulation core, we'll see that we have some enumeration in here, the divisor register, which is the offset for the divisor, the duty cycle register base, basically the one that we shifted it to the lower half of the register map. And what we have here is what's interesting in this is actually the resolution bit. We're going to have to design it in HDL or define it in HDL in here manually. So in HDL, it's instantiated within the MMIO subsystem as 10 bits. So we're going to have to specify it here as 10 bits. There's no way to send some data from the hardware in here. So we're going to have to set it. And here we're defining max, and max is actually the maximum number we reach. So for example, for 10 is actually 10,000, like 1024. It's not from 0 to 1023. It's actually the number 1024. You can obviously just say 2 to the power 10, but just to conserve some computation power from the processor, it's simply just the resolution bit, or 1 shifted by the number of resolution bits, which is basically 1, and in front of it there's a bunch of like zeros, maybe 9 of them. So you can give yourself a couple of examples. For example, if this is 8, the maximum will be 256 exactly. The other functions you'll see is actually a constructor, a destructor, like any of the other cores, any of the other drivers. And here we can actually set the switching frequency for the pulse width modulation by just providing what frequency we want, and we'll calculate the divisor value and write it. The other two functions are actually overloaded functions. They're called set duty, and you can provide it with the duty as a number, as an integer number between 0 and that maximum. So you will have to actually compute how much you want, and you'll have to figure out what the maximum is, what the resolution is, and you do all of these calculations by hand. And of course, you're going to have to provide the channel because you might have up to W of these channels. However, an easier way to do it is to set the duty cycle using a number between 0 and 1. So we're going to define it using double or float. And here it's double, so we can define some sort of a number. And frankly speaking, what this is doing, it's actually using that set duty in here. So technically, you can move this to the private section, but we just basically keep it exposed to the public so that you can use it as an application developer if you need it for some reason or another. And of course, you need to actually specify the channel. So let's take a look about how these are implemented. And as we expect in here for the set frequency in here, what it's doing, it's actually doing that frequency, and it's really computing the value of divisor using an equation we've seen earlier. It's just basically taking the system frequency, multiply it. Well, the system frequency here is 100. Because it's megahertz, we're going to have to multiply it by this million. We divide it basically by the maximum number, which is 2 to the power r, and we divide it also by the frequency that we care about. And it compute the value of divisor, and it just writes it exactly into the register map at that particular location. For the duty cycle, the integer 1, it's actually just keeping duty and just sending that duty here. So what it's doing in here, just making sure that it's not more than the maximum. So you can't send a duty that is basically 2000 while you only have a resolution of 10. Okay, so this is what this is the purpose of here. And what you do then, you send that value and you write it at a very specific location, which is the duty register base. This is the 010 or 10 hex, and you add a channel number because there's an offset from that base. Okay, if the channel number is 0, which you get from here, you just write that value. Of course, you can, so that you don't have to calculate all of this duty by hand, you can specify it as a number between 0 and 1. This is what this is it. So between 0 and 1, 1 being the maximum, so 1 times maximum, you get that maximum. This is the duty. So really what you're doing is you're basically multiplying that f by the maximum, and you get the value of duty. So that you don't have to do this by hand and using this function. This is what this function provides. It's just an easier way to do it. And what it's doing, it's actually calling that function, the set duty. It's technically, if you think about it, it's interesting because it looks like a recursion, but it's not. It's just because duty in here is actually an integer. Okay, so it's calling the other function, not itself. Of course, something to pay attention to is in the constructor, we are providing a default frequency value of 1000 or 1 kilohertz.